Welcome back to Spring into Math 8. Today is the last lesson of Chapter 8, and this topic is solving two linear equations in two variables. Very lengthy lesson, so pay close attention. Here's an example we're going to work on today. We have line A and B, and they only list the sets of coordinates for them. Line A has the coordinates 4, 5, and -4, 2, and line B has the set of coordinates 5, 8, and -5, -5. It asks us to find the point of where these two equations or lines, where lines A and B happen to cross. Let's first start off by finding the slope of line A. Now we can use what we've learned previously and use the slope formula. y2 minus y1 over x2 minus x1. We're going to inset the sets of coordinates we have and solve to find our slope. When we do so, we get 2 minus 5 on top and -4 minus 4 on the bottom. This results in us having a slope of 3 over 8. Now we're going to take that slope and plug it in to help us find the y-intercept. So when we plug it into the formula, y equals 3/8 x plus b. Now we're going to go ahead and have to solve for b. So when we do this, we're going to insert a set of coordinates. In this case, it was 5 and 4. So 5 equals 3/8 x times 4 plus b. Now when we simplify or reduce this equation, we get something like this. 5 equals 12 over 8 plus b. And we can reduce that yet even further, and we get b equals 7/2, or 7 over 2. Now we take the slope of the line, 3/8, and we take the y-intercept, or b value here, and we write it in our nice y equals mx plus b formula we've talked about previously. And we get this equation. Y equals 3/8 x plus 7/2. Now, we're going to do that same process, but we're going to use it for line B and use those coordinates to help us find the formula of y equals mx plus b, or the equation that goes with line B. So we insert them into the formula y2 minus y1 over x2 minus x1. That gives us -5 minus 8 over -5 minus 5. We're going to go ahead and reduce this, and we get a fraction of 13 over 10. Now we're going to use 13 over 10 and insert it back into our equation. Y equals 13/10 x plus b. And we're going to insert another set of coordinates, in this case 8 and 5, to help us solve for that variable b. Now we have 8 equals 13 over 10 times 5 plus b. Let's reduce that or simplify it to 8 equals 65 over 10 plus b. And simplifying it all the way down to the very bottom, we get b equals 3 over 2. We can say that with confidence now this equation of the line is y equals 13 over 10 x plus 3/2. We're going to set the two equations equal to each other now and then solve for x. 3/8 x plus 7/2 equals 13/10 x plus 3/2. Now we need to solve for x. So the first thing we're going to have here at the very top of the screen, we have 3/8 x minus 3/8 x plus 7/2 equals 13/10 x minus 3/8 x plus 3/2. Basically, we're reducing this by moving the 3/8 x value to the other side of our equation. So all variables are listed on the same side. So now we have 7/2 minus 3/2 equals 37 over 40x. We're going to go ahead and simplify that a little bit more. 7/2 minus 3/2 gives us 2 over 1 equals 37 over 40x. Now, we're going to go ahead and do some tricky math here. 40 over 37 times 2 over 1 equals 37 over 40x times 40 over 37. We're going to reduce this fraction down to 80 over 37. And if we turn that into a proper mixed number, we have 2.16. This is the approximate value for x. We're going to plug in the value of x into the equations to determine the value of y now. Y equals 3/8 x times 2.16 plus 7/2 equals 0.81 plus 3.5. This is going to give us the value of 4.31. The point where both lines intersect on a coordinate plane are 2.16, 4.31. That's it for today. Hope you enjoyed Chapter 8. Catch you next time.